Okay, so this is really cool. Um, I don't know. I first thought like, okay, so like I was wondering, okay, so I have this function that I use all the time. It's amazing. It's wonderful. Where is it? Nope, nope. Here it is. This function right here. I use it all the time, this. And I've never understood what this works, but basically how it works, but now I do. But basically what it does is just gives you the direction of the indirect lighting, or the baked lighting, or the light probes, I guess. And basically what it's doing is that I actually did this before in one of my other things more recently, for essentially doing more accurate iridescence. However, and this does the exact same thing, just in a different way. For iridescence, I need to basically figure out like the average direction between the light direction and the view direction to kind of make like more accurate iridescence that looks much better. This is the exact same thing, but basically adding the red, green, and blue indirect lighting directions together and normalizing, which basically gives you an average vector direction. However, I never quite knew what these mean. Turns out this is really cool. Basically, what these two do is that this is giving you the direction of the red, green, and blue channels of the indirect lighting or the light probes. So essentially, you're getting the raw direction data of the colors that are being received by it. So if I go to my text shader, if I just output the uh, the direction of the red color, the direction of the green channel, and direction of the blue channel, and just plop that all into here like this. Here, I'll compile that. Oh, move this over here. Now you can see I'm basically getting the raw data from the light probes, essentially. However, it doesn't quite look quite right. And like essentially I'm getting the raw lighting data from the probes, but it doesn't quite look right. It doesn't have, it's much darker and much more raw. You kind of see it's a little bit weird. If I upload it, we just do this. I'm just upload it. I'm gonna change out of this avatar. And then change back into it. Now you can see we basically have the raw lighting data from the light probes without anything done to it. And we have the direction of the red channel, the blue channel, and the green channel, which isn't existing right now because there's no really green light right now. But you can see how it changes as we walk around. However, it doesn't quite look right because it's the raw data straight from it. But we get the direction of the individual colors, which we'd use to actually do specular highlights. We do a specular highlight for the blue channel, red channel, so we'd have a specular highlight coming from this direction, another one coming from this direction, and the green channel might be somewhere over here, I think. Anyways, we have the raw lighting data. But how do we make it look like actual baked lighting, where it doesn't quite, where it looks more like this, and not like this? Well, apparently, I was curious, and I was like, huh, I wonder if there's anything done in the alpha channel. So I was like, let's see here, or the W channel, because we're only sampling the red, green, and blue. And so I did that, and I looked at this, and I was like, I plugged this in. This is basically getting the alpha channel from the red direction, and we get a color. And it's like, huh, interesting. Okay, well, let's look at the other ones. And they seem like if it was nothing, it'd either return like black, it'd return black if there was nothing there, but there is something there. You can see that it's a little bit different too. It's changing in color. And now, if we add this all together and we output it, or just basically append it together, this looks like the ambient lighting of the scene. Look at that. It's not quite right, but it looks pretty close. So if we add both of these together, essentially, if we add them, it's like kind of like, it's like the base lighting or the minimum light. And if we add it together, well, look at this. We have our indirect lighting, just remade in a different way. And so what we could do is that we could actually access this individual lighting data, plug it into light probes, sorry, not light probes, specular highlights, or I don't know, even like screen space shadows. So we have multi-directional shadows, or multi-directional subsurface scattering, or multi-directional specular highlights, which can add much more depth to avatars. And then we'd use this as the base lighting, or the base, I guess, light color, which will help make things look even nicer. So yeah, I don't know, it's just really interesting. And also we're just dot producting the output of this by the world normal, just so we basically get shading. You can see how this looks. I just plug this in like this, just pointing in the direction. Oh, that's not gonna do anything because there's no red going on here. But yeah, look at that. We're basically in the direction of the green channel right now. And yeah, so if I plug this all here in, upload it to VR chat, just like that. Bada bing, bada boom, change out. And then change back in. See, now it just looks like normal baked lighting. Look at that. Oh, where are we? Yeah, look at that. Look how cool that looks. It's just, basically, we just have access to the individual lighting data of the baked lighting, and it just works. It's beautiful. It's so simple, and it just works. it's just wonderful. Like, look at that. I have access to all that data now, and we can make so much use of that. I know, it's just really cool. You do a lot of really, really cool stuff with that. It just requires a bit of work. But yeah, I don't know. I hope you find that really cool. Yay, like over here, if we go over here, we now blue and such. I don't know. It's just really, really cool to think about that and how that works. And it's just so simple. It just works. Yeah, I don't know. That's that. Yeah.